Okay, this is Mathematical Statistics, section 4.5. We're going to find the mean and the variance of a discrete random variable. Now, x is discrete. Here's an example. It's a hypothetical example. X is the number of overdrafts, and Px is the probability for the given number of overdraft. 5% have no overdraft, 40% overdraft once, 30% twice, 25% 3 times. This is how we find the expected value of x for a discrete random variable. This is going to give the mu of x. We add the entire table. Each x times its own probability. x0 times 0.05. Add x1 times 0.40. Add x2 times 0.30. Add x3 times 0.25. Use a calculator, and you found that all customers together have an average of 1.75 overdrafts. Now, how do we find the variance? Here's the table again. Now, we are finding the expected value of x squared. It's not the variance yet. To do that, we're going to add the entire table. We're going to take each x minus the mean of that table. We just found the mean, 1.75. We know mu is 1.75. So each x minus the mean, we square. That means we are never going to have negative here, times the probability of x. So let's see. Take this x minus the mean, square that, multiply by this probability. Move on, second x minus the mean. Note the mean is the same for all of them, so minus the mean is square, multiply by the probability of the given x1. So this is xi, pxi. Move to 2. 2 minus the mean is square that times the given probability, plus 3 minus the mean, square, times the given probability. Use the calculator, and the variance is there. Okay? Now note, I put this here, but for continuous variables, we don't use this. We have the variance coming out straight because of this formula. Okay? So I rewrote this entire thing in bigger font, so hopefully everybody can see well, that simply we find the variance straight. X minus the mu of x squared times the probability. Move on for every x, add the thing up, got the variance. And now we want to find the standard deviation. We square the variance. Take the square root of the variance, and the standard deviation is that. A very important note, because you should know the meaning of this number. This is a standard deviation, but is it too big? Well, this rule here I created over 20 years of teaching and seeing cases. If the standard deviation is more than 10% of the mean, the standard deviation is too big. There is too much variation. And in a factory or any business, over 10% of variation is just too much. The process is unstable. Now, officially, you can actually do this. This is called coefficient of variation, CV, coefficient of variation. You take the standard deviation and divide by the mean. And of course, if it is greater than 0.10, it's too much variation. You want this coefficient of variation to be, the coefficient is a Q, not a C. You want it to be as small as possible. It's never going to be 0, but you'd rather have a 1% than a 10%. So it's a very important idea to keep in mind.